This is Learning Assessment Problem 311. We're instructed to use the problem-solving strategy of nodal analysis to determine a current in this circuit, I sub O. Since nodal analysis will provide us with information about node voltages, we'll need an auxiliary equation for I0 equals the labeled node voltage V2 divided by 2K. We have a dependent voltage source in the circuit joining the nodes V2 and V1, and its value or strength is 2000 IX. That 2000 would have units of ohms, but let's use 2K there so we're consistent with the units for the other resistances in the circuit. So now we have an I sub X relationship. I sub X flows downward through the 2K resistor connected to V1. So our auxiliary equation for IX would be V1 divided by 2K. And finally we have the supernode here, this voltage source connecting those two nodes. And that supernode relationship is that as a constraint for that voltage source, we have V2 minus V1 is equal to 2K I sub X. We'll label the currents flowing out of that supernode envelope as positive currents in our KCL summation. And now we're ready to write that sum of currents. So we'll do KCL at the supernode. This is the supernode, this envelope here. So we have minus 4 milliamps plus V1 divided by 2K plus V2 divided by 2K plus 2 milliamps is equal to 0. So this gives us V1 divided by 2K plus this gives us V1 This gives us V1 divided by 2K plus V2 divided by 2K is equal to 2 milliamps. We can now substitute We can now look at our constraint equation for the voltage source, and we have that V1 is equal to V2 minus 2K IX, and then we substitute the voltage form for the I sub X. We have V2 minus 2K I sub X we wrote above as being V1 divided by 2K. 2K's will cancel, and this gives us that V1 is equal to V2 divided by 2. So we can substitute that into the supernode equation which we wrote, and we have V2 divided by 2 times 2K plus V2 divided by 2K is equal to 2 milliamps, or V2 times 3 or 3 4K V2 is equal to 2 milliamps, which gives us that V2 is equal to 8/3 of a volt. Now we can apply the other auxiliary equation. We have I0 we can apply the other auxiliary equation. I sub O is equal to V2 divided by 2K. I sub O is equal to 8/3 volt divided by 2K, and this would be 4/3 milliamp.